Hey everybody, welcome to day 12 of NTI. The last couple of days, you guys have been talking about finding the area of a composite figure, so shapes that are made up of other shapes. Today we're going to continue that topic, except instead of looking at finding the area of the figure overall, we're going to be finding the area of a shaded region within that figure. It's very important that you guys are still using that information that you learned from Ms. Beck over the last couple of days, um, because we're still going to be using those same formulas for the area of all the shapes that we're going to be looking at today. And this is going to build into the formative that you guys are going to have at the end of the week. All right, so we've got 2 days of area of shaded region, and then you guys will take a formative over composite figures and the area of a shaded region. All right, so let's talk about how do we calculate the area of a shaded region. All right, so we've got a couple of examples here. On the left-hand side over here, we've got a circle inside of another circle, and we see that we have this blue area between the two circles. That's what we're going to start by trying to calculate the area of. All right, I'm not going to share my calculator on the screen. I'm going to be using my own calculator that's like the ones that we use at school. But I am going to, just like what we've been doing, continue to show my work on the screen. So for a circle, we all know, hopefully by now, that our formula is area is equal to pi times the radius squared. All right, so we're going to have to do this twice because we have two different circles. All right, so if you guys look, you should notice that there are two different colored lines there. There's this blue line, and then there is, forgive me if I choose a color that's not red because I'm colorblind, that line. All right, so those two lines represent the radius of each of those circles. All right, the red is for the smaller circle, the blue is for the larger circle, and that makes sense because that's also the color of those circles. All right, so what I'm going to do is I'm going to break this up into both the large and the small circles. So let's start out with a large circle. We know that the radius is 5. Okay, 5 centimeters to be exact. And for this, let's use pi as 3.14 like what we've been doing in the past. Okay, so we're going to take 3.14, take that radius of 5 and square it, right? So now on our calculator, we're going to do 5 squared times 3.14, and that gives me an area for the large circle of 78.5 square centimeters. All right, and then we're also going to do the same thing there for, we'll move this over here to the side, our small circle. All right, so since we're doing a circle, same formula, a is equal to pi r squared. My radius for the smaller circle is 3 centimeters. So I'm going to do 3 centimeters squared. All right, so 3 squared, it's the same thing as 3 times 3, so that's 9. 9 times 3.14 actually gives me, this time, 28.26. So my area is 28.26 square centimeters. All right, so we want to find the area of this space here that I just colored in. So if you look at it, that space between the two circles, it looks like a donut or a tire. So that middle section has been pulled out. It's been taken away. And in math, whenever we use the word take away, we can use that operation of subtraction. So what we're going to do is we're going to take those two areas, the larger one and the smaller one, and we're going to subtract them. All right, so we've got 78.5 minus 28.26. And whenever you do that, that will actually give you the area of that shaded region. So our area for that shaded region between the two is 50.24 square centimeters. And that is our final answer for that one. Okay, you will have a problem like this on the work for today. This is fair game for a problem that would be on a formative. And it should be able to be completed because we have talked about the area of circles. That was on NTI work from last week. All right, so we're going to move over here to this next one. If you look, let me zoom in on that. So, oops, sorry. So that we're only looking at that one. We can tell that we have two different shapes here, right? We've got a rectangle. Right? And for a rectangle, we know we can use that area formula for a parallelogram because technically a rectangle is a parallelogram because it has two pairs of parallel sides. So we're going to use area is equal to base times height. And then if you look, this area right here, you've got a little triangle that looks like it's been cut out of that larger rectangle. So we're going to use the formula for a triangle as well. A is equal to 1/2 times a base times a height. All right. So for our rectangle, I'm just going to write the word rectangle over here again. And the formula for our rectangle, we can see, and I'm going to highlight the rectangle information in red here, that we've got a height of 12 inches and a width, or the base length, is 20 inches. All right, so again, we just substitute that information in the formula. 12 times 20. Technically, I have it switched around. That's okay. Multiplication, I can do it either way. Doesn't matter what order I do things in there because I'm multiplying between B and H. So the base there again is 20, the height is 12. You can do 20 times 12 there in your calculator and you get 240. My units are inches, so square inches. All right, so this time for the triangle, I'm going to change the color here. I'm going to highlight that in blue. I've got 6 as my height, but if you look, I don't have this base length, right? So how can we find that base length for the triangle? Well, if you look at, I've got 8 as a length here. I've got 8 as a length there. And then I've got 20 for the overall length of the base of this figure, right? So in order to figure out that empty space that would be the base of the triangle, we can just work backwards and take 20 and subtract it by 8 and then by 8 again, or do 20 minus 16, since 8 times 2 gives me 16. And that would tell me then that the base of that triangle is 4 inches. All right. So I'm going to scoot down here and do our work for our triangle. So we've got 1/2 times our base of 4. And then the height of the triangle is 6. So think about half of 4, that's 2. And then 2 times 6 gives me 12. So that is 12 square inches. All right. And then I'm just going to highlight that blue so it's consistent with what we had up top there. So now for the overall area of the shaded region, we're just going to take the area of the rectangle and subtract it by the area of the triangle. So we've got 240 square inches minus 12 square inches. 240 minus 10 is 230, minus 2 more gives me 228 square inches as my final answer there for the area of that shaded region, right? So all we did, we found the area of that rectangle overall and then took out that space. It looks like, again, it's been cut out that is represented by that triangle. And then on this last example here, instead of doing the work for you, here's what I'm going to do. All right, you guys can pause this video at any time. But what I'm going to do is I'm going to give you guys what I got as the final area of the shaded region. All right. I'm going to ask you guys to see if you can come up with that answer on your own, following the steps that we've done in the last two. Find the area of the larger figure first. So in this case, it's going to be that square. So find the area of the square, and then find the area of that piece that looks like it's been cut out, which is represented by the parallelogram. All right, and I'm going to leave you guys there with that. Okay, so I'm going to stop sharing the screen and go back to where I'm full screen. Remember, finding the area of the shaded region, always find the area of the larger figure first, and then find the area of the smaller portion. Once you do that, then you can do what we did in those examples today to subtract the two areas to find the area of that shaded region. All right, once you do that, that will be your final answer for any of these shaded area problems like what we've done. All right, so you'll have some practice to do today. You'll have a little bit of practice to do tomorrow on day 13. And then on day 14, again, you guys will have a formative that'll combine what you guys did in days 10 and 11 with days 12 and 13. If you guys have any questions at all, again, feel free to reach out to Ms. Beck or myself. We are more than happy to help. And we hope that you guys have had a great week and enjoy the rest of your week. See you.